Alright guys, I debated on whether to even show this part. This was a failed top cap, the first piece that I attempted to make. Um, the inner brass that I press fit in came loose after I parted it from the main billet. I attempted to cut slots into the two pieces and silver solder them together. Um, Unfortunately, the outer piece of brass heated up way quicker than the inner piece and caused it to swell and split and crack all over the place. Um, this is basically just to show you guys that um, they don't always work the first time. As a matter of fact, they usually don't work the first time. Um, Here in just a second, we'll actually get started on the actual build. um, this is an excellent paperweight now. Looks like shit too. So here we are. You can see I'm center punching this to drill holes so that I don't have to solder the inner piece to the outer piece. I just figured I'd drill a hole through the outer piece into the inner piece and then drive oversized pins in. It just so happened that I found some copper rod that was 2 thousandths larger than the drill bit, so just happened to be perfect fit. Nice tight compression fit. There are 3 pins on the top, 3 pins on the bottom. The side mounted in the chuck is going to be the bottom deck, and then the side on the outside is the top cap. I had a heck of a time driving these things in, but you can see a few of them went really nicely, and the couple that didn't go in very far I actually pulled out and replaced off camera. And I just turned those down until they were almost flush so that I could do the actual machining process. You can see the lines in the blue that are marked. Those are the actual um, those are basically my depthing marks. Give me an idea of what I'm working with on my material. And there you can see I use a center punch to drive the pins in a little further and try to spread them out a little bit, make sure that they wouldn't come loose. And here we're turning the section of the top cap that will go inside the barrel. Tolerance on this isn't quite as tight because I want the O-ring to be the primary piece that holds it in place. So the O-ring fit will need to be a little tighter, but you guys will see that in a minute. Came out with about 4 or 5 thousandths of an inch smaller diameter for the top cap than the actual ID of the barrel, and that should compensate if it manages to get hot or warm up while I'm using it. When it swells, it shouldn't affect the fit. That was a big problem I had with the machine fit on my first couple Maximus designs. As it would warm up while I was using it, the cap would not be able to come off of it, and it would actually, over time, actually cause the cap to swell slightly, and it caused problems. So this is my solution, is to actually use O-rings like you're supposed to, and leave a smaller dimension there. You can see when I stop occasionally, you'll be able to see the copper pins inside. Here we are cutting the O-ring fit. I started out getting it close and then stop every about 5 or 10 thou and check the O-ring fit, and you can see over and over again that I had to redo this, checking it. And I do finally get it. I think it took 7 or 8 attempts to finally get it right. And it is still very tight. It's a very heavy fit, although even dry, I can press the cap in directly now that it's all done. at least the cap is done. And there you see I slightly undercut where the two pieces will be parted from each other, just to give so I don't lose it while I'm turning the outer diameter of the top cap. And here I decided to bevel the inside of the top cap, kind of angle it up from the outside in so that it'll actually channel the airflow a little bit better. I did cut into the pins ever so slightly on the bevel, and I'll show you guys that, but still really happy with it. There I undercut a little deeper, and I slowed this section down. This is still at 2 times regular speed. The lathe was actually running 58 RPMs. This is actually the part of the top cap that you will grip to remove it from the barrel. And I wanted a really good grip, so I knurled it, and I just knew it was going to come out terrible. It wasn't going to work, and you'll see in just a second. I slowed it down. I didn't want to run at full speed or at regular speed because the video would take forever. But you'll see, I'll zoom in here. The knurl actually came out really, really nice. I'm very pleased with it. There you can see it gives a raised texture to the material that you knurl. That area will require a little bit more cleaning because you do have to use oil when you do that. It is a really, really intense process. It requires a lot of pressure to move the material like that rather than just cutting it, because it actually raises the surface. And then you can just bring it over, get them nice and smooth, get them all the sharp edges off. And I would have to pull the O-ring out and chamfer those edges as well. Even though I hit them with the file, the machine chamfer does a lot better than the file. And after we get these chamfered, we'll start cutting it off in the bandsaw. The parting tool that we have does an excellent job with brass, but the diameter is so large that it gets a ton of extra built-up resistance along the sides of the tool. And it winds up putting far too much pressure on it, and almost inevitably breaks the tool when you try to part off larger pieces of brass. So I just made sure that the undercutting section was large enough so that you can, and well, you'll see in the bandsaw. When I started this, I had my phone mount magnetized to the side of the bandsaw, and you can just see it in the bottom of the picture there. So it vibrated like mad. So here in a second, right there, I moved it to a separate piece so that it could actually see properly. And just the bandsaw took almost 20 minutes to cut through this. Basically, unless you run it as slow as you possibly can with it still removing material, it'll cut at a terrible angle, and I just couldn't afford it to cut. I needed it to be as straight as possible. I can't lose any material. I only have a 130 thousandths worth of free space there. So I didn't want to take any chances whatsoever. I'm just checking it every so often to make sure that nothing is coming loose or getting too hot. I don't want it binding up on the blade. This was a very nerve-wracking 20 minutes for sure. And there it is off of it. Here we are, got it kept around backwards with some stem stops holding the actual section that will go in the barrel. And we're just going to face off the sawn edge. Once I get it face flat down to the center, I will go in and drill through from this side to finish out the drip tip hole. And I decided to stay with a 1/2 inch. That's more than enough airflow regardless. If I leave that at a ½ inch, then if I go more than a ½ inch total airflow on the actually coming into the RDA, that top cap will help to limit that so that it's not just too much airflow to be controllable. Just starting a little bit there so that the drill bits stay on center. And then I played with this a little bit, trying to make it look like the drill bits just instantly grew in size, but of course it's not perfect. I'm not skilled enough with editing to make that look really, really clean. I hope you guys like this camera angle. Let me know what you think. I actually stole well, I didn't steal. I pulled it out of the pile of crap. It's the magnetic base for a dial indicator. And here we are just doing the final facing work here. And I used the auto feed on the lathe to back it out really nice and neat. And I did this pass twice to make sure it was good and flat. But I used the magnetic base off of the dial indicator, an old one for the lathe. The indicator itself had been dropped at some point and broken. The magnetic base still worked, but there was nothing to use on it. It was really old, covered in metal shavings, so I spent probably an hour just cleaning it up. And it definitely makes mounting the camera over top much, much easier. I can get, as you can see, I can get right down on the part and see exactly what's going on, and it leaves my actual working area clear. I'm not fighting a camera stand and a camera to get a good shot and to be able to actually work my parts. And this last chamfer on the top there wasn't quite steep enough. That was about as steep as I could get it, and I'm really not happy. There I am, just doing a little cleanup work. Alright, so that was the machine work specifically for this piece of metal right here. You can see the knurling up good and close. Very pretty. You can see this is the spot that I actually had to, that's the spot that I actually brazed up in the first video, and there are some holes in it, but for the most part it's filled up. You can see in the bottom there, that is where the pins came through, and you can see one of them came through a little deeper. All three of the pieces came through all the way to the edge of the chamfer with copper. So those holes are just where I drilled through a little too deep. So rather than some crazy elaborate soldering job, which I've already proven heat destroys this thing with heat necessary to solder, I'm just going to clean all the extra brass out. I may even take a little carbide bit and waller those out just a little bit to make sure there's no loose pieces in there, and call it good. This is really heavy. To give you an idea of what this is actually going to look like next to the Maximus, yeah, this thing is massive. Here it is mounted in the barrel. You can see very clean. The knurling just barely makes it proud of the edge of the barrel, which is exactly what I was aiming for. Next step in the process is starting work on the deck. That is going to be the most complex piece, because not only do I have to have everything that the top cap does, I also have to have a positive post, 2 ground posts in the insulator. Which you say, oh well, that's no big deal. Well, those take longer than the actual deck does. In my experience from the Maximus, it takes at least a ½ hour per post. Positive post is going to be probably an hour to an hour and a half, because I'm going to mill it flat. It's going to be way larger. But I hope you guys enjoyed this. Let me know if you have any suggestions. I really wish I had my new wireless mic already. It would make the voiceover much better. I really hate the audio quality on the voiceover. I'm stuck with the laptop. I tried to use my Bluetooth headset, but I don't have Bluetooth on the laptop, and I can't transfer audio from the phone. It's a nightmare. So I get the noise from the cord. It does have a regular auxiliary headphone plug on it as well. But anyways, I hope you guys enjoyed watching this. I really enjoyed it actually turning out like I had planned. Here is the piece that will be the deck, and you can see the pins there. The only concern I have with this, which is a pretty significant concern, is that, we'll just set that right there. You can see the deviation on the bandsaw right there from top to bottom cut. The only concern I have is that these pins are too high up to be able to part this, or to leave a lip around the deck, which I've got to have, or the juice will just flow out like mad. I had originally intended for the deck to be another 1/4 inch taller, and I mean, I was aiming for 20-25 mils of fluid in the deck. It's still going to be a lot, but I'm not going to be able to have the edges as high as I was hoping for. And of course my laptop goes into screensaver mode. But there it is. Put the star of the show up here for you guys. I've done enough of these now that I did not sit down and draw up a full blueprint ahead of time. I literally just have been doing this one piece at a time. I did sit down and lay these pieces out and mark everything out and write it down on a piece of paper. I've got all the measurements written down, all the thousandths of an inch and everything, exactly as this piece is and exactly as this piece will be. And I will show all of that in the final video. There's no point in showing it now because there's no reference for what it's actually going to look like, and the pictures aren't to scale. It's just hand-drawn. There's a lot to be said about hand-drawn your layouts ahead of time. Whether it looks pretty or not makes a huge difference, being able to just throw your ideas out on a piece of paper. If it doesn't mesh on paper, it's certainly not going to mesh in real life. Anyways, that is the top cap finished. Come on, piece of junk. There it goes. Once we get the deck done, we can part the barrel to proper length, and we'll be ready to rock and roll. Vape on, guys.